Hey guys, welcome back to another video. Today we're going to be finding some gradients with in multivariable calculus. So let's read this problem first. Find the gradient of f of x, y, and z equals yx plus sine of z at 1 to pi. So that's what we need to find here. So first things first. So the first step is to find f subscript x, which is also df over dx. Step number 2 is to find f base y, which is df over dy. And finally, the third step is to find f base z equals df over dz, and then we can move on to the real problem. So in this color, let's find f base x or df of dx. So now, since there's x, y, and z, we treat y and z as constants. So yx, right? Yx. So, actually, you know what, let me write this down. So which equals d over dx of yx plus sine of z. Okay? Well, what's the derivative of x? That's 1. And y times that 1, since y is a constant, would just be y plus sine of z. Sine of z is a constant, derivative of a constant is 0, so we're just left with y. So now, let's do this one. This is d over dy of yx plus sine of z. Okay, what does this equal? Well, derivative of y is 1 times x, which is a constant, so x times 1 is just x. Okay, and sine of z, well, since z is not the same thing as y, that's a constant, and that the derivative of that is 0, so we're just left with x. Now this is equal to d over dz of yx plus sine of z, right? Well, yx, right? Since those both are constants, since we're doing in respect to z, y and x are constant. A constant times a constant is a constant, so that would just ends up being 0 plus sine of z. The derivative of sine of anything is the cos of that, so cos of z. Okay, so now we're left with f of x, y, and z is equal to y, x, and cos of x. So we can put this as y, x, cos of x, or we can also put this as, this is sort of useful, we could also put it as y, x, and cos of x. They're the exact same thing. Okay, so our next step is to substitute, since we have x, y, z, but they're giving 1, 2, and pi for x, y, and z respectively. So now let's substitute them in. Okay, and I'm going to do it in this matrix kind of form, this vector kind of form. So let's see, that would equal, this would equal y, which is 2, right? That's 2 in that case. X, which is 1, and pi, cos of pi. Using the unit circle, we know that pi is we're doing this in radians, cos of pi. So that would be equal to, let's see, if I draw a unit circle, right? If I draw a unit circle, pi would be over here. So this would be negative 1, 0, negative 1, 0, negative 1, 0. So this is the cos and this is the sine. So -1 is what cos of pi is. So 2, 1, and -1 is our answer in vector form, but you could always write this as 2, 1, and -1, and that is our answer. And I hope you had fun learning this. Don't forget to click that subscribe button, click that notification bell for newest videos, and see you next time.